We've been talking about defining the metadata for a data table, and we've talked about the name and the description of the file, as well as saying something about the structure of the file, in this case, a text file. But we haven't gotten to the most important aspect of metadata for tabular data, and that's the metadata that describes the columns or the attributes that are being represented by the tabular data. You can see at the bottom of the Easy EML screen here that it gives you the opportunity to add columns for a table. Now I have to have a name for a file before I add columns, so I'm just going to call this data table test, and I'm going to edit column properties here in order to add metadata for a given column. And the very first thing you realize is you have to know what type of data you're going to put in the column for somebody else to be able to use it. Whether that's categorical data in terms of categories of an experimental design or something like that, or maybe site categories. There could be numerical data, that's just numerical values representing measurements. More generically, it could be text information, or it could be something more structured along the lines of time in terms of being some sort of date time code. So for as an example, if we look at numerical, then we have two things that are pretty typical here, a name and some sort of description, or in this case, definition, that's telling us what is the contents of this table. We're going to talk a little bit more about maybe how to break that down. There's lots of also information. For example, if you have a number, you really care about the units to understand the scale of that number and what that number means. The type of the number, whether it's a real number or an integer, something like that. Typically, those are the two that are the most important that we think about, whether it's a counting integer or a real number. You might have information about uncertainty in terms of a precision. These are all more optional things. Different missing value codes, the most common one being NA for not available. This gives you the ability to have more than one missing value code and explanation for that. I'm not a big fan for having more than one missing value code, but sometimes you don't have a choice in terms of the data that you're getting might have more than one code that you want to characterize. So there's lots of information about each column, and that is absolutely critical for somebody else to be able to use some form of tabular data that you're providing in a product. We can start adding some information about the columns of our data table in our R code. So if I go back to our processing script, one thing we haven't talked about yet is that in RStudio, you have a quick way of navigating your code based on known elements of the code. For example, RStudio recognizes that in R Markdown, you're going to have things like headings. So if you click on this bottom breadcrumb bar here, it will automatically recognize things that it recognizes out of R Markdown, including headings and subheadings, as well as chunks. And if you name your chunks, you can quickly go to the chunk here by name. If you don't give a name to your chunk, it's just going to number them like this. Another way you can navigate your code quickly is via the outline. Over here in the upper right, there's a button that says outline. And if you click that, it will bring up the outline of the headings specifically. Now, there isn't going to be anything about code here. This is specifically about Markdown. So this is what it finds the headings in the Markdown and lets you jump quickly to those headings. So that becomes really handy as your code becomes longer and longer. And in this case, we want to jump to our right table section. So before we defined the metadata for a table with a path, a format, and a description, but now we want to add metadata about the columns, and we're going to do that with another table. So I want to go ahead and be more specific in my heading here, and say write table and process metadata, because this section is going to be doing more than just writing the table. It's also going to be processing metadata for that table. Now I have a table with 3 columns in it. Therefore, I need a table with 3 rows, each of those rows describing a given column. So here at the bottom, after I've defined my table and reported on the generation of my table, I'm going to start a new R chunk. And within this chunk, I'm going to define a table that I'm going to then write to the product folder as a comma delimited file, which means I need metadata about that file, similar to how I needed metadata about the table file itself. So I'm going to call the metadata for this ATTR, standing for attributes. And as with the other metadata, I'm going to need a list with multiple elements that are going to tell me about this file. And as before, I need a path. I need a format. And I need a description. But this is a table of metadata, and I want to pass that metadata on as part of this data structure. So I'm also going to have a table here that actually has the table of metadata in it. So in addition to a description of the file I'm about to create, I'm going to put the table itself in here for later use later on in my workflow. Okay, so we need to define these the same way. I'm actually going to do some cutting and pasting here, because what I want to do is very similar to what I've done up here for the table itself. So I'm just going to cut and paste in here to get myself started. Again, I'm going to paste together this name with the deployment name so that I've defined the deployment name once, and I want all of this to automatically populate my file names here. But instead of table CSV, this is going to be table meta CSV. So it's the metadata for the data table. The format of the file is just like before. It's a text file in CSV format. So it's a UTF-8 text file with comma delimited tabular data. And then a description. In this case, I need a different description. I'm going to be table of, actually, I'm going to just replace this text, metadata describing column attributes in the data table for deployment. And again, I'm going to take that dep name string variable and I'm going to pump that data into my description using the paste function. I need a comma after this. So just like before, I've described the file, but I'm going to actually describe the table here, and I'm going to put it with the metadata. It is metadata table, such that I can use this table later. I don't have to reload it separately. It'll just be loaded as part of the metadata that I'm passing on for later in the workflow. And I'm going to use the rbind function to put together multiple data frames that have information about each column of this data table. And rbind, in this case, I'm going to be combining data frames. So it's going to be a single row data frame I'm going to construct for each column. And the elements are going to be the following. First of all, what's the variable? This is what needs to match up with the table in terms of what we're describing. So this is going to be the same as the table heading. And this is going to be the cross-reference so people know which column specifically I'm talking about. I need to know the type of variable. So similar to the easy XML, we have to give it some sort of structural information about what's the data type that's in this column so I know how to read it in with a computer properly. What is the form of that type? And we'll talk about examples of what we mean later. The type is just the data type that you need to read in, but then you need to say, well, what is the form of that type? How do I interpret whatever that information is in that column? And we'll talk more about that in a minute. And then there are three elements that I think make a good definition of an attribute. And that's the three different things you need to know, because an attribute, an evaluation of an attribute is going to tell you three things, or you need to know three things to be able to use them. First of all, what's the property that you're evaluating with that attribute? What is the entity that you are describing with that evaluation? And what was the method that you used for determining the evaluation of the property? So this is what I like to think of as a relatively complete way to describe just about any column content for a data table that you're including in a data product. Now, I don't want to bore you to death with me typing a bunch of stuff here, so I'm going to start copying and pasting some material from my notes. But first, we want to describe each column of our data table. That means we need to start with the first column. Makes sense to go in the same order as the columns in the table, and that's time string. As a matter of fact, let me go ahead and bring up this table just to remind us what we're dealing with here. I'm going to bring it up in my Notepad++ text editor. And recall that the first column is this time string. The type is a character string. So this is a pretty classical name from computer programming for any time you're talking about text format. So we have a character string that we want to read this in as, but this character string has a very specific form in terms of how you interpret the sequence of characters that you find in these character strings. And to define that form, it gets a little bit complicated in this case. So there's going to be a lot of material here, so much so that I need to paste it to keep my code narrow. First of all, this is a UTC Gregorian date and time. Ultimately, what you want to interpret this is as some sort of Gregorian date and time. So we know a year, a month of year, a day of month, etc. And the format that we want to use is one that's internationally recognized. So we're going to use the International Standards Organization 8601. That's a definition of this format. But somebody who just reads this is not necessarily going to know what ISO 8601 means. And they may not even know what we mean by Gregorian date and time. But ultimately, how do we define this? Well, we can be very specific. So I've gone ahead and put a colon and a space here. And then I've started saying in abstraction what these things are. So a lot of times we use these caret brackets to say this is something, an abstraction of what goes into the spot. So the first thing is a 4-digit comma error year. That means the first 4 digits of this are a 4-digit year, 2021 in this case. Common era just refers to the reference date of what 0 was in that number 2021. A 2-digit month of year. So the next 2 numbers represents the month of the year. In this case, it was March. A 2-digit day of month. That's the day of the month is next. Then we have a T, and that's just to break up the date from the time, because the next 6 digits are going to tell us what the time is, starting with a 24-hour clock, 2-digit of a 24-hour day, 2-digit minute of hour, and 2-digit second of minute. And finally, at the end, there's a Z. That represents Zulu time, which is another name for UTC. So this is a full definition of what the form is of how you interpret this data type character string that is in the column time string. So that is specifically in a very formalized way what is in the column, but we haven't really described it in the abstract yet in terms of what it means, and that's what property, entity, and method are for. So in this case, the property is a particular instance in time. Pretty straightforward. I like to keep my properties pretty short as I can in terms of being concise of what the heck does this measurement represent. And in this case, it's just an instance in time. Now the entity that we were describing here, remember this is metadata, right? What goes in this column is metadata. And what we're describing is a data logging event. This is the time, a particular instance when a data logging event occurred. And we can be a little more specific that we're talking about a Campbell data logger that's out there in deployment. That's what I mean by an entity. What is this property? What are we trying to describe with this property? That's what belongs in the entity. And finally, some sort of relatively short, we'll have the opportunity to elaborate on this later, but for now, just what's a short description of the method? What's something that somebody's likely to be able to recognize if they're at least a little bit familiar with what they're dealing with? So they don't have to look at the details to figure out what method would use to measure this, just kind of a reminder of the method. In this case, the method is coming from a Campbell program. The Campbell program's running on the Campbell data logger, and it's using the real-time clock of the logger to pull that information and stick it in the data. So the method, the way I've characterized it here, is the Campbell program using the data logger real-time clock. So that's an example of one property, entity, and method that I've been talking about. And I think in terms of, I can try to define what this means, but giving lots of examples really helps to clarify what I mean by the difference between a property, an entity, and a method. Okay, so that was the first column. Now we need a second column. So after the definition of this data frame, I need a comma, and I need a new data frame. I'm just in the habit of going ahead and putting in the closing parentheses every time I put an opening parentheses, just especially when I'm typing a lot of stuff. That way I don't forget it. Now, similar to the previous one, we need the same information. So I'm just going to copy and paste this again from my notes. The first thing we need is the variable. In this case, the second column of our data frame is the column with par in it, the par data. We need to tell it the type. Now, ultimately, it's a text file, so the data type of the raw data is just text, but how do we want it to interpret that text is what's important here. And the data type of this text is we're talking about a real number. So the series of characters, it should be interpreting as a number. In other words, if you read this in, you're probably going to be turning it into a numeric data type as opposed to a string. And that's emphasized in the text file itself because there are no quotes around this. And that emphasizes even further that you shouldn't interpret it as a text, you should interpret it as a number. So the type is a real number. Now here, for a number, this is where the form becomes important because this is where units come into play. That you see a number, but in order for that number to have some sort of meaningful form to it, the number has to have units. So this is why I describe the form of this real number as a quantity in units of micromole photons per square meter per second. And in this case, I don't like to use abbreviations. I like to spell out units all the way in the metadata because who knows, I mean, there's always the SI standards for abbreviations, but if people don't know those standards or it's a thousand years in the future, and we're not using those anymore for whatever reason, there's still at least some hope that people know what we're talking about here. So we've got a form. The next thing we need is property, entity, and method. So let's get the property over here. Oops, I put it in the wrong place. One more row down. Right there. There we go. In this case, the property is approximately vertical flux of solar electromagnetic radiation. So this is giving information about the property we're measuring, and that property includes, in this case, the orientation of the probe. Because we get a different number if this probe were put in a different area, and that's actually a different property if it's taken in a different direction. So we've got approximately vertical flux because the probe was pointed straight up or as close as we could get it, which is why I'm using the term approximately, of solar electromagnetic radiation, so radiation coming from the sun, in the photosynthetically active bandwidth between 400 nanometers and 700 nanometers. That means it's not all the radiation coming from the sun, it's a specific bandwidth of radiation, and I need to be specific about that in my metadata in terms of the property we're measuring. So this one's a little bit longer because there's some qualifying terms in here in order to make sure people know exactly the property we're measuring. I've got entity coming up next. In this case, the entity is atmospheric conditions. So what does solar radiation describe when you're talking about it here on Earth? Well, it's one of the quantities of atmospheric conditions at a given location on the Earth. So I'm talking about unshaded. I'm being clear that there aren't any trees around. So there's not any kind of vegetation or buildings or whatever that might be shading this measurement. Atmospheric conditions approximately 1 meter from Earth's surface. Like, it could be taking this at a lot of different depths. Now, I don't know exactly where it was, so again, I'm using the word approximately, but these are on fence posts, T-posts. And I can put that as when I clarify these methods. And those T-posts are maybe about 1 meter tall. I don't actually know how tall they are, but I'm going to call it roughly 1 meter. And then be honest in the rest of the metadata that we don't actually know specifically what height above the Earth's surface were. That just wasn't important for that level of detail for our use of these measurements. And finally, the method that we used. So in this case, I want to say something about the type of data logger and transducer we use. So as a Campbell data logger, calculation of a 5-minute average of 30-second interval radiation measurements from a LICAR LI-192 quantum sensor. So not only do I say the data logger that we used and the transducer we used for measuring it, but also I'm acknowledging that as part of the method, the program is doing some calculation work here. It's actually measuring every 30 seconds, but it's only recording that in a log file every 5 minutes, and it's averaging those 30-second measurements over 5 minutes, and that's the number that you're seeing in the file. So that's a critical part of the method in order to understand the context of these par measurements that are in that are in this data product. The last column in our data table is this QA code column, which will have either an NKP for no known problems in there, or somewhere along the line here, there is an unknown equipment malfunction or UEM code that's in place of this. So we need to define that column as well. So again, we're defining these as a series of data frames that are binding together. One more data frame. I'm going to go ahead and get a few characteristics here at the same time. So we have a variable, a type, and a form. The variable, again, is matching the column header from the table, QA code underscore field. The type is a character string again. So in this case, it's a character string, but in this case, it's a categorical character string because we have two categories that we know about. There's an NKP or UEM that it might be, and that's the definition of an enumeration in computer science talk, or basically the same thing as categorical data. So I'm going to go ahead and get the property, entity, and method here from my notes. Paste them in. The property is a quality assurance code determined by the field technician. The entity is a measurement of par flux in the same record. So we're talking about the quality assurance code that the technician decided this is the appropriate code to use. And of course, it's going to be up to the technician to figure out what all codes there need to be to characterize all of the different ways they can think about these data, maybe having some issues. In this case, it's pretty simple. All we're trying to do is characterize why we don't have data in some cases. And then the entity we're describing here is a measurement of the par flux, and specifically the one that's in the same record as this quality assurance code. So again, this is metadata, so the entity that we're describing is something about the data that's in the file as opposed to being something in the real world. And finally, the method that we use here it's going to be part of the field deployment protocol, and it's the judgment of the field technician that's in place here. So it's basically a subjective. And there's subjectivity in science. There's nothing wrong with that. We just have to be clear about where and when we're being subjective. So this is a bit of a subjective decision. It could be objective as well. There might be some criteria that the objective criteria the field technician is using. But either way, whether it's objective or subjective, we need to be clear about how it was determined. So that is the method for this last part of this table that is defining the column metadata or the attribute metadata for our data table. I think we have an extra comma here. Yes, we don't need a comma after this rbind because that's the last element of this list. I'm glad I caught that because that does sometimes cause error in R. Okay, so now we have our full definition of the metadata for our attributes of our data table, and we've put that into our metadata structure so we can use it later in our workflow. That was a lot of typing without any checking to make sure our code works, so it's probably about time that we save this. I'm going to open up the processing R script for rendering the metadata, and I'm going to go ahead and run this. Now, as of yet, we haven't done anything with metadata in the report, so we're not going to really look at what comes out of this rendering of our markdown yet. But I do want to run this to make sure it runs. We have a bug. So the way I'm going to check for this bug is to go back to my processing, and I'm guessing that this is happening 471 to 534. Yep, it's happening in this new chunk that I've created. So somewhere I've got a syntax problem. And I'm not seeing it immediately. So I'm going to go ahead. First, I'm going to double check that I'm using my current working directory when I run chunks. And I'm going to go ahead and run this chunk here from our studio and probably get more information. I've got an argument missing. I've probably got an extra comma somewhere. So paste 0, quantity in units. There it is. See, this is what happens sometimes in R. You have an extra comma that there is nothing after it. There are some functions that don't like that because they don't have abstract arguments. And in this case, we had an extra comma here. So now I'm going to hit Control-Shift-Enter to run this whole chunk. And now it runs clean. So that was a pretty easy one to catch. And now we can take a look at this metadata. If I hit $, I have an ATTR and a table element to this metadata. By the way, remember metadata is an environment, so I can look at what's in that environment using the ls function from earlier in the class. So if I do an ls, but I give ls the argument metadata, I'm asking specifically for the variables that are in that environment. And you see I have an ATTR and a table. So metadata $ATTR is going to be a list, and I have the elements of that list, a path, a format, a description, and a table. So metadata $ATTR table should look like a data frame. And I have columns that include, this is hard to look at in this particular form, but there's the variable column, there's the type column, there's the form column, and here's the property column, the entity column, and the method column. So now we've created this metadata and we've got it into an R data structure, but we want to start putting things into our data product as well as into our report. First of all, we probably want to write our table to our product now that we've created it. And again, this is the table of metadata describing the attributes of the columns. So we've got write table. We need to define what we want to write, and that is, whoops, table. The file is path. We want to make sure it's comma delimited, so we want to give it the separator of a comma. And we want to make sure that row names aren't included in what we write, so we're going to set row names to false. So we're going to write table as a text format file. We're going to tell it which data frame we want to write into that file, and that's the table of element of the metadata attributes list. And we've got the metadata attribute path here that's defining the file we want to write it to, and that's going to be in the product directory, comma delimited, and don't put row names. We want to have some information here. Again, I don't want to bore you with all my typing, so I'm going to do something similar to what I did before in terms of putting information in the report about what's going on in the code. So I say I have comma delimited column metadata table written to the text file, and I'm using that same path. Again, I'm putting asterisks around this because I want it to be italicized in the markdown. The file format is, well, it's the format that I've defined up here. And the description is the description that I've defined up here. So now I've got a machine interpretable version of all this metadata that allows me to just pipe that information directly into the report. So with that, I should be able to save this. And now there is stuff going into my report. So if I run this, hopefully I haven't introduced any new bugs. First, we should see in our product directory a new file. And remember, we've used that par deployment or that deployment variable as part of the file name. So we're sure that we've got the same base name for the file name, but instead of it being table, it's table meta. We can look at that quickly in, I think it's a little easier to look at it in Notepad++, so I'm going to open that up in Notepad++. And it's asking me to reload because it rewrote this file. And yes, I want to do that. So I've got a variable column, a type column, a form column, a property, entity, and method. It's a little hard to read this in text format, especially, let me turn off text wrapping. So you can see we have one row per column. There's a time string, par, and a QA code field. And then you can see the text information that we have that we included in terms of what's defining our data products, attribute metadata. So we've written that file, but if we look at, remember, we're working with the processing. So that's under incremental, the processing notes. I can open that up in my browser. And you can see that under the heading writing table and process metadata, not only do I have information about the data table being generated, but I also have information about the metadata being generated. One last thing we can put in this report is the metadata itself. Why not go ahead and have the metadata in the report so we have a little bit more human readable version of that? And we can do that in our code. Going back to our processing with one more line where we can call the knitter package function table and send that send the data frame with the attribute table to cable such that I get a quick and dirty tabular version of the metadata piped directly into my report. Going to rerun this. And then refresh this. And we can see that metadata that we just created by binding those data frames together in a tabular form, variable, type, form, property, entity, method, and time string, par, and QAQ fielded columns with their descriptions included.